So any problem with the configuration here, only this particular computer will not be in the network, but all other computers work normally in this star topology. In the network, the entire data is going to divide into a number of packets. Here the systems or nodes are connected in the form of a circle or in the form of a ring. It is called as ring topology. Tree topology is nothing but it is a hybrid topology because it is a combination of more than one network. Students, welcome to Computer Science classes. I am Ravi Kumar KR, lecturer in Computer Science, Vidhyaashram PU College, Temple of Excellence, Mysuru. Students, let us start our discussion with the chapter networking concepts, and in this session we are going to talk about network topologies. This is the topic to be covered in this session. Now let us see what is a network topology. So here the actual appearance or layout of networking is called network topology. So what is the meaning of topology here? See, suppose if we have a number of computers and it is not possible for us, or we cannot connect all the computers as per our wish, as per our requirement. So here we have to follow the protocols of networking, or we have to follow certain rules in networking. That is nothing but network topologies. So topology, here we are going to learn how we are going to connect different computers in a network. So based on this, we have different types of topologies. So first one is star topology. What is star topology? This topology consists of a central node to which all other nodes are connected by a single path. So just look at the diagram here. This is star topology. In this, see, this is a central node. For example, this is one central node and all the other computers are connected to this individually. So from here you connect to one, this is second computer, another computer, and this is one more computer. If you look at the diagram here, this is centralized device, so we say node, and to which all other computers are connected individually. So this is a star topology. And here, what is the advantage of star topology? Ease of service. Means this provides easy access for service or reconfiguration of the network. So one of the advantages is that, so here servicing and configuration is very easy. That is one point of this. Second one is one device per connection. In star topology, failure of single connection typically involves disconnection of one node from another, otherwise fully functional network. So what is the meaning of this? Now look at the example here. Now as it is, all these computers are connected individually. So this is a separate network. So if at all any problem with one of the connectivity or configuration here, only this computer will not function, but entire network will be functional. That is the advantage of this star topology. So any problem with the configuration here, only this particular computer will not be in the network, but all other computers work normally in this star topology. So that is the advantage of this, and it is the diagnosis and fault finding is very easy. That is the meaning of ease of service. That is another point of star topology. Next one is another type of topology, that is bus topology. What is bus topology? Here, this consists of a single length of the transmission medium onto which the various nodes are connected. So if you look at the diagram here, see, these are all different terminals or different nodes in a network, and this is a single line. So this is the main transmission cable. So this is the main transmission cable, and onto which all other nodes are connected. That is bus topology. So here a single length of wire onto which other nodes are attached or connected. So here data is transmitted from or within this cable or in the main transmission cable. The transmission from any station travels to length of the bus in both directions and can be received by all other stations. The bus has terminator at the either end which absorbs the signal, removing them from the bus. So here how data is travel? The data is travel on entire cable, for example from this end to this end on both the direction. So in that way, so the data is transmitted, and this is the data received by a particular computer, but the data will be keep on moving from one to another end throughout the network. And data is transmitted in a small blocks known as packets. So in the network, the entire data is going to divide into number of packets. So each packet has some data bits plus header. It contains the destination address. So what is the meaning of this? So here the data is transmitting over the network in the form of packets. So each packet has two division. There are two parts, and one part for address of the destination computer, second part is for data. So accordingly, whichever the data or whichever the address belongs to any of the computer, so while data is transmitting through this, the particular computer which absorbs the data and other things will be keep moving on the network. Then identifying the address on the network packets copies the data onto its hard disk. Suppose any data is transferring to this computer, it picks up the packet and the particular data information copied onto that particular computer's hard disk. See, that is how this bus topology works. And what are the advantages of bus topology? One is short cable length and simple wiring layout. And it decreases the installation cost and also leads to a simple, easy to maintain network. So bus topology, the advantage is that short cable length, we may not require more lengthy cables here for the networking, and it's a simple wiring, installation is very simple and is very cost effective. Next one is resilient architecture, and there is a single cable through which all the data propagates and to which all the nodes are connected. So this is same what we have seen in the diagram. So in this topology, this is the one cable onto which all the connects or nodes are connected to form a bus topology. Next one is easy to extend. So additional node can be connected to the existing bus network at any point along its length. So one of the advantages is that suppose I would like to add one or two computers in a network, or we would like to extend the computer, so that configuration is very easy in bus topology. That is bus topology. Now, what are the drawbacks of bus topology? So here the fault diagnosis is difficult and isolation is also difficult, and repeater configuration and nodes must be intelligent. So what is the drawback of this? Here in a bus topology, if at all if any one of the computer node is not functioning, then the entire network will be down. So no other computers cannot transmit data to another computers. That is the main drawback of this. And here these are the different drawbacks of bus topology or linear bus topology. Next, we move on to next one, that is called ring topology or circular topology. Now, what is the definition? In this type, each node is connected to two and only two neighboring nodes and is transmitted onwards to another. Now, look at the diagram here. Here, the systems or nodes are connected in the form of a circle or in the form of a ring. It is called as ring topology. And here, as per the definition, this node, for example, this node is connected to two nodes like this and one for this. Similarly, this node connected to previous node and next node. See, here each computer will be connected to two different nodes, and data travels in one direction only from node to node around the ring. So here, suppose any data, it travels in one direction, mostly in clockwise direction. So from data will be keep on traveling over the network in clockwise direction. and after passing through each node, it returns to the sending node, which removes it. So suppose any data sent from one node to another node. So the particular node which has been addressed, it picks up the packet, and remaining data, it goes in the circle or in the form of in the network cable or in the network. That is how this ring topology works. And what are the advantages of ring topology? It is a short cable length and it requires minimum cable length for configuration. No wiring space required. I mean, it won't require much space, and it's suitable for optical fiber, that is OFC. And these advantages. And what the drawback of this? Node failure causes network failure. Suppose in a ring topology, if one of the node if doesn't work or any fault with that, problem with that, then entire network goes down. So no one in the network can transmit data to other computers. That is one of the drawback of this ring topology. Difficult to diagnose the faults. So it is, fault detection is very difficult, and network configuration is also difficult. So configuration or reconfiguration of any node in a ring topology is again a tedious job or very difficult. So this is about ring topology. Next one is tree topology. What is tree topology? The shape of the network is that of an inverted tree with central root branching and sub-branching to extremities of the network. So it looks like a tree structure. What is the meaning of tree structures? You can imagine like this. Suppose this is the root of a tree. I can imagine like this. This is a tree and these are the branches. You can assume like this. And this is here, we can have one LAN, that is local area network, and this is another network devices, maybe it's a computer 2, and this another computer peripherals like computer 3. If you look at the example like, so this is the one root. From here, the trees, these are called branches of a tree. So the network, it looks like this, or the connection will be in the form of tree structure or inverted tree. So here, look at the example now. See, this is one centralized network, or this is one hub, centralized node, and to which this one computer is connected. And from here, if you look into this is another hub, and this is one more network. This is another network and is connected to this. So here it is just like a root, and this is one branch, another branch. If you look another branch, again this is separate one network connected through a hub, and similarly this is one independent computer. So one independent node. So this is called as a tree topology, where we can assume that this is the root, and from it, so these are all called branches. So we can assume these are the branches, and all the branches, we have different type of networks, and all these are interconnected in the form of inverted tree. It is called as tree topology. Now in the next slide, so here transmission in this topology takes place in the same way as in the bus topology. So in the bus topology, what we have seen, the data transmission takes place throughout the network, throughout the transmission cable from one end to another end. So same way data transmission takes place here. And tree topology, it is best suited for applications which have hierarchical flow of data and control. And it is, since topology is a modification of pure network topology, bus topology, it is a hybrid topology. So tree topology is nothing but it is a hybrid topology because it is a combination of more than one network. If you look at the diagram here, if you look into this is one network. This is a star topology, and here also we can have bus topology, and these are two independent nodes. So it is the definition of hybrid topology. Next one is graph topology. So what is, look at the diagram now. It is an example of a graph topology. Here all these are nothing but different computers or computer peripherals. So here in this topology, nodes are connected together in an arbitrary fashion. A link link may or may not be connected to or more nodes. So here if you look into this particular node connected to this as well as this. There are two nodes for this. Now if you look at this example, this particular node connected to 1, 2 as well as 3 nodes. So this is an example for graph topology. There may be a multiple link also. It is possible to have more than one link or multiple links. It is not necessary that all the nodes are connected, but if a path can be established in two or between two nodes via one or more link is called connected graph. So suppose it is not necessary to have multiple connections, but it has to be connected to the network, and data can transmit from one to another node maybe in one path or maybe more than one path by passing through different nodes. That is graph topology. Next one is mesh topology. So what is mesh topology? So in this topology, each node is connected to more than one node to provide an alternative route in the case of any failure. So what is the meaning of this? Look at the example here now. In the previous graph topology, one computer or one node will be having either two or more than two, multiple. But in this also, look at this example. This is one node, second, third, fourth, fifth. There are 6 nodes, and from one to another node, there are multiple links or more than 2 or 3. In this example, so this is connected to this and also connected to this, connected to this, and this also connected to this, and this is connected to this. So in that way, each node most probably you will be connected to all other different nodes in a network to form a mesh topology. And it is an excellent for long distance networking. I mean, the advantage of this because it provides extensive backup, routing and pass-through capabilities. So what is the advantage of this? Suppose any data you want to transfer from this computer, suppose there are many paths. Either I can transmit data in this example from here to here directly. Suppose anything problem with this cable or with this network, so data can transmit through some other path by following different links or passing through different nodes. That is the advantage of this mesh topology. That is the meaning of extensive backup routing or backup path. Now, communication is possible between any two nodes on the network either directly or by passing through. So, directly I want to, for this another, directly from here to here, data can directly to this can be passed through this, or it can take some other path by passing through different nodes in a computer. So this is mesh topology. Now, the mesh topology is commonly used in large internetworking environment with stars, rings and buses attached to it, and this is also ideal for distributed networks. So this is also another example for mesh topology. And when in a network, each host is connected to other directly, and there is a direct link between each host, then the network is said to be fully connected. I mean, one node is connected to all the other node directly. That is the meaning of, that is the mesh topology. Students, so in this session, we have discussed about the different topologies, means the way we are connecting computers in the networks, maybe star topology, ring topology, bus topology, and tree topology, graph as well as mesh topology. See, these are all the different methods of connecting computers in a network. Now, let us continue our discussion in my next session. Thank you very much.